Hello, everybody. I'm Pascale Rouault. I'm going to start my presentation on research and development challenges and outcomes in asset management and digital transformation. I'm working at KWB, and I am responsible for the department on urban system, and with a team of about 9 researchers. KWB is Kompetenzzentrum Wasser Berlin, was founded in 2001 as a non-profit organization for applied research. We are working on the urban water cycle, and in my team we are really focusing more on topics linked to the urban drainage and the impact on the receiving water, and that the topic are all linked with climate resilience, nature-based solution, digitalization, and stormwater management. In the context of asset management, which is a big topic in our team, we are used to link our know-how on infrastructures with our know-how on digitization. And you will see we are working on 2 topics. The most advanced one is the topic of sewer system, and the second one is the topic on drinking water wells. Our experience in that began in 2012 with the evaluation of the performance and applicability of sewer deterioration models. We continue our work with the development of model tools for sewer rehabilitation and inspection planning, with the optimization of sewer inspection and rehabilitation strategy, the quantification of uncertainties in sewer deterioration models. We fill the gaps in some data sets, transfer our methodology and tools to other cities than the one we use or we began to work with. And we are also working on new indexes for evaluating the index or the condition of some sewer pipes. And now we have a new topic, and that really profits from our former researches. We are now working on the aging forecast of drinking water wells. We used to cooperate with the network operators, research institutes, engineering consultants from Germany, France, Bulgaria, USA, and Colombia. In this presentation, I don't have the possibility to show you everything, but don't hesitate to contact us afterwards if you need some more details, or if you want to look into the publication that we have done, into the work that we have done, if you need some demonstration of the tools that we have now. The first topic I wanted to present you is what the tools for sewer rehabilitation and inspection planning. For the tools, we address one of the main challenges for the operators. That's really that the infrastructures is deteriorating continuously, and they need to invest a lot in the rehabilitation of the sewer system and, of course, of the inspection. In this context, and in collaboration with them, we developed 2 types of tools that they are using now really actively. One tool, which really enable to predict the condition of the sewer today for the pipes where you don't have any idea of their conditions. And this tool called SEMA Plus Pipe Simulators enable to answer 4 questions of the operators. The first one is, what is the real condition of the network today? Where is the greatest risk of failure? Where do I have to conduct a systematic inspection? The second tool that we have developed is the SEMA Plus Strategy Simulators, which is really forecasting the condition of the sewer system in the future. And in this context, we're answering also some questions of the operators that are, how will my network condition develop in the future? Which investment in which strategy do I need for a secure network operation? and what is the maximum target condition I can achieve with my current resources. The SEMA Plus pipe simulators enable to prioritize the pipes with a high probability of severe defects for targeted inspection and rehabilitation. It is based on the machine learning model that we have developed considering all the data that we had. We did that for the city of Berlin, and we had a lot of information about the sewer characteristic, so the sewer length or the material and so on. But also we considered some environmental factors. And with that, you can see the rate pipes, that the pipes that we are predicted to have severe defects and that could be inspected first. What is really interesting is if the operators are going to do the inspections. So what we can see with these pictures on the left side is that they are only find 6% of the pipes in very bad conditions. And if they use our tool, they're able to find 25% of the pipes in a very bad condition. So please have a closer look of this picture. You will see this color code a few more times in this presentation. The red really represents sewers in very bad condition, and the green one in good condition. And we have been working with 4 categories, but of course it's possible to work with more categories in some other situations. So what we can see is that the pipe simulator had about 4 times more sewer pipes in severe damages. And so it enables the operators to have a more efficiency inspection strategy. Let's have a look now of our SEMA Plus strategy simulators, which is doing some long-term prediction for sewer network condition and strategic rehabilitation plannings. This tool relies on some other models. We are working this time with statistical survival curve models and not with machine learning model, because we want to predict the situation in the future. So it's really better to use this kind of model. And what we are considering is this so-called survival curves that's really said what is the part of the sewer system in which condition depending of this age. And we have some information for different kind of sewers. For example, if you have a sewer of with brick materials, or you have some clay sewer but for stormwater and so on, and depending on that you can define some different survival curves. What we also consider for predicting the evaluation of the sewer system is the impact of some different activities. So for example, of the renovation of, if you repair, what will happen with your sewer system. And what we would also consider is some external influences, as for example, if you are not able to rehabilitate or to do the work that we like to do, because you need to do some works because of, for example, streets reparation or something like that. So so you have some external boundary condition that you have to consider, and this kind of condition can be also considered in our strategy simulators. What we can do is to simulate the condition of the sewer system over the time. And so you can really compare as an operator, you can use this tool and to really compare some different strategies. On these pictures, you can see what happens if you do nothing, what happens if you only renew your system, and what happens if you do a mix. And of course, it's not possible to do nothing, but for the operators, they have to find a good way to work and a sustainable way to work. So that's why they can implement that. Of course, we don't only calculate this number, the share of pipe, in which condition. We also give some information about the price, about the edge of the sewer system, about so we can do some other evaluation, but I think that's one of the evaluation that's really, is really important. Important is to know that we develop these tools only because we're able to trust the models that we had to do the prediction of the condition of the sewer system. In the work that we have done on that, we could notice that the prediction was we only had a deviation of about 1%. So we are so happy with that, that we were able to have the trust of the water company and to rely on that to develop the tools. A second work that we have done is to work on the model uncertainties. And what we wanted to do was first to identify the uncertainties and to quantify the uncertainties. So the identification of the uncertainty brings us to see that, of course, the subjective condition assessment can be a problem and source of uncertainty. Some low data availability of some type of sewers, for example, from plastic pipes, or you can have some uncertainties due to survival bias. And what we were able to do is to predict the uncertainties for the different strategy. So you do not only, at the end, you do not only have what will happen with the strategy, but also what kind of uncertainty you can have with that. That enables the operators to also reduce their uncertainties if they want to work on them. And I think it's a very valuable result for the future and for the operators. Another work that we have done is to fill the gaps in the sewer asset data. As you know, every city have gaps in the data. For the city of Berlin, for example, we were missing about 12% of information of the age of the sewer, and of course it's a source of uncertainty for your prediction. We work with two types of models to fill this gap. The first one, and I think the most powerful one, is to work on the nearest neighbor. But what happens if you don't have any neighbor? Then for that, we develop some random forest model based on some other information, for example, of the age of the pipes in the catchment, in a bigger catchment, and so on. So, but I cannot go into details on that. But what is important to notice, it was possible to close the gap and to do some accurate prediction for most of the pipes. And so we can really reduce uncertainties for the strategy simulators based on that. The second challenge for the operators is a challenge of managing the drinking water wells. In Berlin, we have about 650 water wells, and their capacity is decreasing with the time. Due to some iron ochre formation, biofilling, or clogging. What does it mean? It means for the operators that for a given water demand, it requires a higher energy consumption. So that's a critical topic now. And what does it mean? They have to work on the maintenance. They have to work on their well renewal strategic planning. But at the moment, they don't have really the possibility to have some strategic planning on that. And that's why we decided to rely on our experience and to try to use the kind of models or knowledge that you develop on SEWA asset management for the wells. What we did first is to really understand the data. And in this context, you have many different types of data. Of course, the well age, which is important to predict the aging, but also the number of rehabilitation or some operational context or information, but also some water quality factors that can really influence the aging of these wells. And then, based on that, we were able to better understand and develop some machine learning model that enables us to predict the efficiency of these wells. That's the picture that you can see on the right side. What we can also do now is really to predict the well capacity. And as you can see on this picture, is at the beginning, you have a capacity of 100%, which is decreasing. And if you are doing some maintenance actions, you can come back to this 100%. But then, if you are under a specific critical value, you cannot come back to this capacity. And so now we are able to simulate, we are able to predict the situation, which means that we are able to work on that and to predict the maintenance, better predict the maintenance, and do some strategic decisions based on that. But they are really our first results, and we are continuing to work on that. My conclusion is that digital tools can help to solve some two important challenges in infrastructure asset management we worked on. The SEMA Plus simulators can support utilities in strategic planning of SEWA rehabilitation and inspection programs. Important and uncertainty sources and countermeasures are identified. Data gaps can be filled with reliable machine learning-based prediction models. Machine learning-based prediction of well capacity can help to plan rehabilitation and renewal of wells and reduce maintenance costs and energy consumptions. So I was really happy to share with you all these results. If you're interested, contact us. If you're interested to share some experience, to ask more information about our solutions, and to tackle some future challenges with us, please contact us, don't hesitate. In this context, I would like to thank my team, Matthias Rischel, Nicolas Carado, Hauke Sonnenberg, and Hella Schwarzmüller, as well as our colleagues from the Berlin Water Company. And I will be really happy to discuss later on this context with you during this workshop. Thank you very much.